All right, hi everyone. So this video today is going to be about the second method of long division. The other day I showed you the reverse box method, and so today is going to be the typical, the more standard kind of procedure and process. Okay, so first things first is we're going to take this polynomial, we're dividing it by this root. Okay, and so the first thing we got to check for is our polynomial, is our dividend written in standard form, and in this case it's not. So we're going to have to make sure x squared plus 4x minus 5. We're going to have to make sure that the exponents go highest to lowest. Okay. Now we're going to set it up just like we would a long division problem with if it was just numbers. Okay. So writing in standard form, and then making sure that includes terms with coefficient of 0. What that means, let's pretend we had an example like this, x squared minus 9. Well, what's missing in there? If this was our problem and we had to write it underneath, we'd have to write x squared plus 0x minus 9. It's important because it's a placeholder. That 0 is an important thing. All right. So this example doesn't have the 0, but just to make sure that we understood what the words meant. Okay, so step one, write it in standard form. Step two, write it in the division. Okay, now it's time to work. Okay, so it's all about how do we make, and I'm going to use a different color to kind of point it out. How do we make this x look like x squared? So I have to multiply x by something to get to x squared. Well, x times x is what gets me to x squared. Okay, now I'm going to take this x and distribute it to both of those. X times x is x squared. X times negative 1 is negative 1x. Now, I'm going to declutter a little bit. And so what I'm going to do now is I'm working my way down, and I'm going to take both of these blue terms and subtract them from that red term. The red term's right above it. Okay, so this is just like long division of numbers. We're going to say, and the reason why I put it in parentheses is because we are subtracting, and I think it points out the subtraction is going to change the signs a little bit. So x squared minus 1x squared is 0x squared. 4 minus negative 1 is 5x. And then I'm going to bring down the 5. When you do this, you should be canceling out terms. So that's why that x squared goes away. And now it's time to move over. How to make this x look like that 5x? Well, what would I have to multiply by? Well, to go from x to 5x, I'd have to multiply by positive 5. Okay. Now, when I do that, sorry, I'm just going to try to declutter and change a little bit so it stands out. I'm going to take that x, this 5, and distribute it to both of those. So 5 times x is 5x. 5 times negative 1 is negative 5. And like before, I'm going to put my subtraction in parentheses. 5x minus 5x goes away like it should, because that's the point. And now negative 5 minus a negative 5, because minus minus becomes plus. I get a remainder of 0, meaning this right here is our final answer. So for this polynomial, I have, in this case, I have a parabola because it's x squared. I have a root at positive 1. That's from the original problem. And then the answer, the reason why we did the division is so that we can get the other one, the other x-intercept, the other root. Okay. Now, if you get an answer here, a number here, or a letter or whatever, that's just going to be the remainder, and we'll talk about a couple examples that have a remainder later. Okay, so first example, and then I'll show another video with example number 2.